Welcome to Problems on Trains, Session 1. The topic Problems on Trains is very much similar to time and distance. Or you can say that problems on trains are a special case of time and distance. So here also you have to calculate distance, speed and time taken by the train under different conditions. The only difference is the object length. So here the length of the train as well as the length of the object and that the train crosses must be considered while solving a question. For example, if the length of the object is very small like car or a pole, that should be neglected. But if the length of the object is bigger than these objects, that must be considered, like length of the train, that must be considered while solving a question. And then there is one more important thing is the direction of the trains. So you have to be careful and you need to check every time if the direction of the trains is same or different. And yes, you have many specific formulas in this topic and most of the questions will be formula based. So don't forget to memorize these formulas to save your time. In this topic, session 1 will be having types of questions, points to remember, formulas for problems on trains, formulas for boats and streams, and some sample questions. Session 2 will be having sample questions based on problems on trains. In session 3, we will see sample questions based on boats and streams. In session 4, we will study questions from previous papers, and session 5 will be having a practice test for you. Types of questions based on trains. Time taken by train to cross any stationary body or platform. Question may be asked where you have to calculate the time taken by a train to cross a stationary body like a pole or a standing man or a platform or bridge. Time taken by two trains to cross each other. Another question that may be asked is the time two trains might take to cross each other. Trace problems based on equations. Two cases may be given in a question and you will have to form equations based on the condition given. Some important points to remember. Relative speed of trains moving in the same direction. When two trains are going in the same direction, then their relative speed is the difference between the speed of two trains. Relative speed of trains moving in the opposite direction. When two trains are moving in the opposite direction, their relative speed is the sum of the speed of the two trains. Distance covered when two trains are moving in the same or opposite direction. When two trains are moving in either the same or in different directions, the distance travelled will be the sum of the length of both the trains. Distance travelled when a train crosses a stationary object. When train crosses a stationary object or man, the distance travelled by train is equal to the length of the train. Distance travelled when a train crosses a platform or a bridge. When a train crosses a platform or a bridge, the total distance covered is the sum of the length of the train and the length of the platform or bridge. Formulas for problems on trains. If a train passes a small object like a pole or a man, then the length of that object will not be considered. If a train passes a big object like a platform or a bridge, then the length of that object will be considered. If two trains are moving in the same direction at u meter per second and v meter per second respectively, where u is greater than v, then their relative speed is equal to u minus v meter per second. If two trains are moving in different direction at u meter per second and v meter per second respectively, then their relative speed is equal to u plus v meter per second. If two trains start at the same time from point A and B towards each other and after crossing they take A and B seconds in reaching B and A respectively, then A speed is to B speed is equal to square root of B is to square root of A. Points to remember in both sand streams. In both sand streams, most of the questions will be formula based. It's just that sometimes you will have to use the formula directly and sometimes indirectly. In water, the direction along the stream is called downstream and the direction against the stream is called upstream. If the speed of a boat in still water is x km per hour and the speed of the stream is y km per hour, then the speed downstream is equal to x plus y km per hour and speed upstream is equal to x minus y km per hour. If the speed downstream is a km per hour and speed upstream is b km per hour, then speed in still water is equal to a plus b divided by 2 km per hour and rate of stream is equal to a minus b divided by 2 km per hour. Question 1 based on train. Two trains P and Q start at the same time from A and B, which are 120 km apart. If the two trains travel in opposite direction, they meet after 1 hour. If they travel in same direction from A towards B, then they meet after 6 hours. What is the speed of the train P? There are two trains and 2 points A and B from which trains start. Now, if they travel in opposite direction, they meet in 1 hour, but in the same direction, they meet after 6 hours. The question looks complicated, but with the help of the formula, it becomes very easy. We have learned the relative speed of trains in opposite and same direction. Let the speed of the train P is S1 and the speed of the train Q is S2. So, relative speed in opposite direction is equal to S1 plus S2 and relative speed in same direction is equal to S1 minus S2. Speed is equal to distance upon time. So, S1 plus S2 is equal to 120 divided by 1. This is our equation number 1. And S1 minus S2 is equal to 120 divided by 6. This is our equation number 2. From these two equations, we can calculate the values of S1 and S2. So from equation 1 and equation 2, S1 is equal to 70 km per hour. So our answer is 70 km per hour. Question 2, boats and streams. A man takes 3 hours 45 minutes to row a boat 15 km downstream of a river and 2 hours 30 minutes to cover a distance of 5 km upstream. Find the speed of the river current in km per hour. We know the formula for rate of current, which is rate of downstream plus rate of upstream divided by 2. So we need to calculate the rate of downstream and rate of upstream first. Let's convert the hour and minutes into hour to make our calculation easy. So 3 hours 45 minutes is equal to 3.75 hours and 2 hours 30 minutes is equal to 2.5 hours. Speed is equal to distance upon time. Distance is 15 and time is 3.75. So, rate downstream is equal to 15 divided by 3.75, which is equal to 4 km per hour. In the same way, rate upstream is equal to 5 divided by 2.5, which is equal to 2 km per hour. Now speed of current. Rate downstream plus rate upstream divided by 2. So speed of current is equal to 4 minus 2 divided by 2, which is equal to 1 kilometer per hour. So our answer is 1 kilometer per hour. Thank you for watching session 1. If you have any query, you can write back to me on mathskagurukul.vns@gmail.com.